The talk today is Lisp, the ultimate Excel Lambda, or Excel, the ultimate Lisp REPL. And it's partly inspired by, that title is partly inspired by an announcement that Microsoft had almost a year ago about an upcoming Lambda function that they're adding to the next major version of Excel. And I didn't think to put the link in the slide here, but it's easy to find. Just so look up Lambda, the ultimate Excel spreadsheet function or something like that, and you'll find it. The idea was within the confines of the Excel function language to the formula language to come up with a Lambda concept. And so they had previously added let, and so you got let, you got Lambda. It was pretty well received. A lot of people have a lot of interest in it, but when I saw it and I looked at the syntax for it, and I suppose I can go find it just to show it to you, but the syntax is quite cumbersome in my opinion, and I don't think it's at all easy to teach to people who don't even understand what lambdas are. So I had this notion, well, what if we could put a real lambda in Excel? What if we could like a nice, simple, clean scheme code or closure code or any kind of Lisp? And so alongside the original concept of the product for Accelerate that we had, which was to legacy modernize Office desktop data silos and turn them into proper microservices, linked data microservices, I said, well, we could do better. We could add this right inside Excel. Why not? So that's usually how these crazy ideas get started. It's a big what if. So let's go through the preliminaries. Some of this we talked through before the recording, but I'll say it for the sake of the recording. My name is Bob Calco. I am Chief Architect, Lead Developer at Apex Data Solutions. We are a product company in Tampa that has done considerable previous work in the primarily the data interoperability space. We've worked with very large government organizations on a data federation solution and applied it in a clinical setting to medication reconciliation. So we learned a lot about that problem, and a large part of what I'm working on, which I'm getting to here. Okay, let me just step. A large part of what I'm working on was inspired by that experience, the good, the bad, the ugly, and everything that I learned has really helped me focus on what I think the real problem is in data interop. My road to Lisp, which we talked about a little bit before, I didn't really properly discover Lisp until around 2015, when I was looking for some alternative storage facilities for a concept I have for a database, and I discovered Datomic. And Datomic was fascinating. It kind of hit a lot of the right sounds in my head, sounds good kind of thing, like that sounds right, it resonates. And so we explored that with the Cogtech people. We built some pretty interesting prototypes and demonstrations that we were able to show at HIMSS conference in 2017. And that got me into Clojure, obviously. And Clojure was when it really clicked for me what Lisp is and what, the sheer simplicity and the beauty of S expressions and how you can express almost any kind of computation you can think of in it. And particularly because of macros, right? The whole idea of homoiconicity of the language. And when you really grok what that means, it's like, whoa, I don't know if I need any other language. I can make the program be what it needs to be. And so that lets me think the way I want to think about a problem. And that's, I think, the big lesson from Lisp is how you think about the problem is the problem, but you can change it. And you're not constrained by the language per se into any particular mental model for the problem. I think that's what really makes me, kind of a proud Lisper. And I've dabbled in all of them since Common Lisp, LFE, which is a Lisp 2 on the Erlang virtual machine, Clojure, which is a port of Clojure to the Beam architecture, Scheme, which I've, kind of after learning Clojure, I appreciate actually how they have a similar, they're far more similar than say Clojure is to Common Lisp. There's a little bit more going on that's in common between Scheme and Clojure. They're both Lisp 1s. They both have slightly added syntax to the normal Common Lisp. Some people love that, some people hate that. I don't think that that's not a big deal to me. I got less expressions, I've got home iconicity, and I got some facility for meta programming. I'm happy. Let's see what else I got here. Okay, so I'm here to tell you a little bit about what I'm working on. It's all very much work in progress. We're approaching a kind of an RC1 release, and so the demo isn't going to be as full featured as I had hoped, because things always take more time than you want, but I think your interest will be piqued anyway. It started off, like I said, as a kind of a crazy idea about a year ago. Can we possibly do lambdas for real, and within the confines of Microsoft Excel's formula engine language? So let's see, on the agenda, we'll talk a bit about my motivation for integrating a proper Lisp into Excel. What problem does it solve? How does it compare to Excel's upcoming Lambda function? In thinking about how I kind of put these sheets together, I don't necessarily want to delay the conversation. So let me just make this point now. We're not trying to compete with the Lambda function. Seeing that Microsoft itself had seen value or discovered a value in exposing the concept of lambdas to spreadsheets so that people could kind of write their own user-defined functions. That really intrigued me. And if I liked everything about what Lambda does, I probably might not have done this, but I saw the syntax and I was just like, I think it's easier for lay people to learn, the simplicity of scheme versus this. When you see some of these examples, like they have one for the factorial function, it's like, it's like unreadable to me. Now, I guess if you're an Excel aficionado, it's maybe not so strange looking, but I still couldn't imagine why anybody would want to do that if you could do, a proper Lisp. And so part of this is just a theory I have that this will be easier for lay people to learn and a lot easier for normal Lispers to jump in and do some interesting and compelling things with Excel. So we'll talk about the good, the bad, and the awesome. There is some ugly, but I'm doing my best to hide most of that from everybody. There are some lessons already I've learned in working on this that I'll convey at a high level about Lisp and .NET and Excel and Office. Sometimes you just got to open Pandora's box and find out what's inside. On some level, you think about opening the spreadsheet in this way, and you can say, "Oh my Lord, this is really blue sky here." This is the idea of a spreadsheet, and in concept is very similar to functional programming. You want sort of your inputs to always be the same, your outputs. What if we introduce this possibility of breaking referential transparency? Then are we going to cause damage? Well, I got news for you. Excel, while purely functional in the sense that you get inputs and outputs, it is a meditation on breaking referential transparency, if you really think about it. The model's already sort of, you can't guarantee what you're going to get out of it. It's deterministic, but there's lots of ways you can introduce non-determinism. There's add-ins that people have written to do stochastic modeling, which obviously are now completely possible in Scheme, no problem. So the stochastic modeling is actually an opportunity to break outside of the deterministic bounds of Excel. And Lisp as sort of a first-class strategy to deliver user-defined functions and add interoperability functionality is really kind of the heart of Accelerate 365. That's what we're calling the standard edition. That's the heart of it. It's also about other things, which we'll talk about. But in terms of today's demonstration, that's what I'm focusing on. So we'll talk about where does this leave VBA? What about the new JavaScript style add-ins? All of these are great questions, which I'm not trying to replace VBA. I see a kind of a tag team there between VBA and Lisp. The JavaScript style add-ins, I don't think they're really proven from a performance point of view. I mean, if you think about it, if every formula has to make an internet web call, well, when every time the spreadsheet recomputes, I mean, that's a lot of network traffic. So I don't, a lot of VBA people originally, if you read the VBA books, they're like, this is kind of scary. What do we do? Do we all have to learn JavaScript now? But I think they've settled on, yeah, VBA is not really going anywhere for a couple more decades until they figure out this performance issue with the JavaScript style add-in. So VBA is really there. I think there's an opportunity to reach out to the VBA community and work with them to take what are basically these kind of monolithic sort of GUI desktop database and spreadsheet apps and convert them without leaving them into proper, linked data microservices or just utilities of any kind you can imagine. I mean, you're not limited to the idea I have for them. That's why I like the openness of it being a proper Lisp. A spreadsheet as a REPL. Well, you think about it, it kind of is already. So adding Lisp is surprisingly comfortable. I'll talk a bit about my lessons learned, what to look out for and to avoid, what to embrace. These are things I'm still learning, so this is not necessarily a definitive guide. Just my first impressions, having got to a major milestone in what we're working on. A bit about our roadmap and what we're planning to do with all this. Sharing it just for informational purposes. Anybody that likes this idea and wants to work with it, you're free to take it wherever you want. In that sense, you're not limited to my vision of what I want to do with it. But I will share that. And then we can have the Q&A. All right, so back to the motivation here. Given that Excel is arguably a kind of REPL and its formula expression language is a kind of functional programming, what if we could define one-off Lambda expressions in a proper Lisp as user-defined functions? What if we could actually use Lisp but not the formula engine? What if we could give these Lambdas both Lispy and optionally an Excel name and reuse them pretty much everywhere? Like, what if we made these things completely reusable? What would that look like? Oh, and can we have a REPL, please? I don't know, at this point, I was kind of, it was a late night point. I was thinking here of literate programming, but if you think about it, people document what they're doing in the spreadsheets. So in a sense, it's a kind of literate programming. If you think about all the different ways that the Office apps can interchangeably use content from one and another to compose, PowerPoint presentations or Word documents to explain things. In a way, we could attain a kind of literate programming right inside the application. I don't think that's what Donald Knuth had in mind per se, but I definitely think it's a thing. What if we could make them work with both SQL and NoSQL data and linked data even? I have a lot I'm pulling into the product at the moment from an integration point of view here that unfortunately I'm not going to be able to show today. I promise though, the next time I have an opportunity to speak, we'll show off both closure CLR and some linked data goodness in this context. Whoops, wrong button. There we go. And what about turning desktop spreadsheets and databases, all these desktop data silos, into microservices? And again, that's something for a future demo, but I'm actively working on integrating basic web serving from right inside an Excel or a Word or an Access document. It's not a particularly sane idea, of course, but not totally insane either. In any case, it's fun to experiment. And that's kind of the joy of Lisp, right? You can play with things, try them out, error, see things go right, they see things go wrong, figure it out kind of in a zone. You're in a zone when you're doing that. And it's all about getting into the zone. Okay, and we can have fun. All right, so the good of what I've learned, Excel's already a REPL. And Lisp feels right at home there. You think about it, you type in a formula, and if you type it correctly, you get a response that looks right. If you don't, you get an error. It's like, okay. And you're iteratively, progressively building your model out. You start moving stuff around, so you copy and paste like formulas over here and over there, and then you come up with layout. So it's all very iterative and it's all very responsive and immediate. I kind of marvel that nobody thought of this before. Working in Excel is like working in a Lisp image, only the image is the document, right? In a sense, the document storing your code with everything else. And so that document is the image for the application you're working on. It actually is an easier concept of an image, I think, to convey to non-Lispers. When they say, what's image-based development about? Scheme's a particularly good fit for Excel. A lot of mathematical precision behind the language and its standard. I'm sure most of you are aware of the books by the SICP crowd on differential geometry and classical mechanics. And by the way, one of my little pet projects is to maybe on some open source forum on a GitHub, take the code from one of those books or both and put them in a form we can import them into Accelerate. And now you can do Lagrangians and Hamiltonians and everything right there from within Lisp, namely Scheme. So when you think about financial functions in particular, there's just a lot in the Scheme world that addresses things that would matter to an Excel user. The bad. All right, so Iron Scheme and Clojure CLR are both inhibited a little bit by .NET limitations. Continuations in the case of Scheme aren't really first class on the CLR. There is a call CC, and as long as you call it and use it within the lexical scope of the continuation you're defining, you're good. The minute you do it outside of that, you get a friendly message telling you can't do that. And that's just because neither the CLR nor the JVM really let the programmer have that low level of control of the flow of things. It's just not there. If you go to Kawa Scheme, which is the equivalent of Iron Scheme on the JVM, they don't even bring up continuations. They kind of like skip over that subject because it's the same problem there. On .NET Core, both Iron Scheme and Clojure CLR can't really compile their code to native code. And that's only because Microsoft, for some inexplicable reason, a few years ago, before .NET Core came out, decided to change reflection emit. So all these clever language programmers who were using reflection emit to generate assemblies, all of a sudden couldn't do that on anywhere but Windows on the .NET framework. I know that this is an active area of people complaining with Microsoft, and Microsoft may be eventually going to get to putting that back together again. And I know that there's some exploration of alternatives to reflection emit for these languages, but in the near term, the upshot of it is you get a little bit of a performance hit when you run it on .NET Core. Now, although this isn't relevant to Accelerate within the Office context, I have had, and for the Pro edition, I have command line applications that do run on .NET Core. And I will tell you that once the application is running, it's blazing fast, it's particularly on .NET 6. So it's really just an upfront hit that you take. And it's a significantly bigger hit for Clojure CLR than Scheme, because Clojure CLR, as it starts up, if it doesn't find it already compiled, it compiles the entire Clojure library. So all the things you're used to seeing in the core Clojure library get compiled. It takes about 8-10 seconds. And then once it's up and running, you're fine. Iron Scheme was never really designed to be a compiled language. It really does allow compiling to speed things up, especially with heavy use of syntax extensions and macros. But by and large, he wrote it to be a fast scripting engine, and originally that was the concept. So I'm talking about Llewellyn Pritchard, really done a good job optimizing the performance of that as is. So even on .NET Core, you don't feel it. And then keep in mind, on those other platforms, you have Mono still around. And the latest Mono runs the .NET framework assemblies for these just fine. So you could, in concept, precompile them for Mono on Windows, move it to Linux and Mac and be fine. But these are all little complexities that are really about squeezing the last ounce of performance out of it, not really fundamentally a design problem. The only design problem is you can't really do first-class continuations in Iron Scheme, but you can do most kinds of continuations that you would practically use. A lot of the stuff in the Scheme standard that explains what continuations are run fine. It's just like I say, when you try to access a continuation outside the context it was created, and then you got a problem. And again, unless you're building new languages in Scheme, which is kind of like the use case for that, you're not likely to really run into it. Office add-in capability is really complex, at least as complex as the Office COM object model, which is huge. And this is why it's good to make friendships with VBA programmers, because they know that model inside out and upside down. There is really no problem from within Iron Scheme accessing the COM object models and putting a nice schemey, Lispy interface around them. I'm sure there will be lots of activity among programmers and Accelerate 365 for that, kind of specializing maybe in some area of it or something. We will be providing standard wrappers of the COM object model and make it easier. But the first initial release won't have a full-blown wrapper of all that yet. The add-in capability in Office is kind of an interesting world to work within. One thing you learn is that other add-ins can affect you. So you have to take special care to, keep good boundaries and be a good add-in citizen. And don't assume when there's a problem that it is necessarily yours. It could be, and it's always good to look for that. But if you might want to ask customers what else they got running, because add-in models don't really give you precise guarantees about how events fire, when they fire. You'll learn it just by working in it. And I've found that it's actually quite stable. If it wasn't stable, they wouldn't be putting that out. But it is not an easy thing to kind of get your head around at first. The memory model is also something to be cautious about. One of the things I just recently really implemented fresh is this notion of keeping one environment per document. In Scheme, you have ability to create environments, and the fundamental eval concept says eval, then you give me some code, and then tell me what environment to evaluate it in, right? So there's this whole concept of creating and managing environments. So, I found that I had to do that because the top level interaction environment is common to anything you open in the app. So if I open three spreadsheets and I start doing stuff like naming functions or whatever, particularly if you use lambdas because of the way that I name them, it's quite easy to have them start clobbering each other. So they needed some isolation. So we've taken care of that in this, and you don't have to worry about that in our context. But that's a lesson learned. Just know that everything in all these open spreadsheets are sharing the same GUI thread, and protect yourself accordingly. Debugging right now is kind of a work in progress, but at least we have a REPL. By the time we go pro, I will have debugging as a kind of thing you can step through and all that, but it's a little bit more experimental in this case at the present, but the REPL tells you good stuff and generally catches the errors that you can catch. It's always possible to bring Office down. I would recommend not doing that, but I guess certain commands you can intentionally do that with. But the debugging isn't so bad. I have one of the things I'm working on integrating now is a console log, so you can kind of see what's going on, and you can enter logging statements and all that stuff. So it's good poor man debugging in the standard edition. And if you could look at and compare it to like the immediate window in the Visual Basic environment, it's better than that. So we're getting there. All right, now the awesome. This is the stuff that gets me excited and really gives kind of helps me stay busy when I'm getting really tired. And before I mentioned the REPL, yes, we actually have a REPL inside of Office, and that's quite fun. We open up the spreadsheet to any and all code ever written in Scheme and in .NET. And if you think about it, that's a massive expansion of capability. There's almost no limitation to what you can do. Now, there are ways to do it that are better than others, and we're still working on those, but we'll be documenting the best practices as we roll out and learn with you. It opens up the programmability model of Office to some interesting alternatives. The idea of documents as microservices, which I hinted at, notion of legacy app modernization, and this is where we need to recruit the VBA folks. That'll be one group I also want to show this off to, and I'll have more of a VBA interaction focus for that, but I think that there's a potential good match there. Now, the really, really awesome is what we're doing with data interoperability, and in the interest of time, I'm not going to explain it, but the core concept here is if we can take these desktop data silos that are written in these, in proprietary Access or Excel formats and functions, somewhat cobbled together by subject matter experts and maybe some people they had on staff who knew a bit of VBA or could learn it. It's kind of a messy world, but there's a lot of valuable data to be recovered from that. And And there should be a cleaner path to making that something you can stand up quickly in a services environment where the data now can speak the language of the domain at a higher level, the enterprise data model, the elusive enterprise data model. All of that becomes possible now, and in ways that it really wasn't before. Unfortunately, like Microsoft's notion of making it enterprise ready is just upsized to SQL Server. But there's more to the concept than that. And the interoperability problem really needs a solution that is driven by the kind of solution, the kind of way of thinking about the problem that you get with, say, RDF. That really does provide an information model you can work with in the context of multiple sources of information having to exchange information where they all have different pieces of it. Okay, so the demo. We're just going to do a quick run through of our Lambda functions and the REPL. We're not going to include other parts of the application at this time. Like I said, I do promise to do a full walkthrough demo in this venue or at the nearest earliest opportunity if there's interest. Okay, let me pause there. All right, all right, so we're inside of Excel. I don't know, maybe it makes sense. Okay, let's see how it looks. All right, in a second, this is a debug version, by the way. That's why it's a bit slow. It's not super fast anyway, because there's a whole bunch of other things loading in Excel. But once it's up, you're ready to roll. Let me just move this out of the way for now. You'll notice I'm working on a template that's going to actually be part of what we ship, so that when you open it up, you have some organization to your coding. There's a Lambda tab where you can set your workbook search paths, any library imports you want. I don't know if you're familiar with Scheme, but Scheme RSR6, which is what Iron Scheme is based on, has a very structured way you can.
Is it possible to increase a little bit the font?
It's challenging. I don't think so on the REPL, because right now I don't have the buttons hooked up to increase the font. I can, yeah, that's something that I can try to increase the, that's just for the, okay, that's not going to help that. Go back to one. Yeah, oh geez, no, don't want to go there, sorry. What happened here? Here we are. My magic mouse is going crazy with me here. There we go. I really can't, unfortunately. Is it that hard to see? Is it?
It's okay.
Yeah, I'm kind of sorry about that. I didn't even. I'd have to do some recompiling or something, which is not a good idea. So okay, so let's make do. I'll explain what's here, and the transcript of this I can copy and send out as a note afterwards if it's helpful. So basically, what we have here, this tab is really where you organize your lambdas that you give names to, and it also sets the environment. Every workbook gets its own environment, and we can see that by just giving it a test. So we're asking what's the ultimate answer? Of course, it's 42. All right, so that shows that we have a working environment. It's sane. This is something that I define when on startup, just so it's there. You'll see when I do my insert lambdas that I use this just to get a lambda started for you. There is a huge amount of code that you can actually access already without importing more. So if I say eval environment symbols. Oh yeah, that's another reason I did this. This is actually the name of the environment that Lisp needs. So copy and paste that here. Okay, and I need to do this in the interaction environment because it doesn't exist in its own environment. Okay. Boom. So you can see there's a huge list of functions already available for you to call into. It's basically the entire RNRS library that you would expect, like if you were to open another scheme, plus some stuff that's specific to Iron Scheme and CLR wrapping. There will be even more by the time we're done. I'm going to have at least 3 or 4 wrapper libraries in Visual Scheme that deals with the model of the application you're in. So there'll be some macros and some functions that we'll explore. I'm not going to belabor those right now. I just wanted to give you a feel for that. What I want to show instead is how do I take something from the REPL that I want to do and make it useful as a function. So let's start off with testing a Lambda. It'll be your typical factorial. I'll do this little bit of hocus pocus here with the word recur. I don't mean to offend Clojurians with that, my use of this. In this context, it strictly means the Lambda I'm defining right now, call it. Because behind the scenes, the Lambdas aren't as anonymous as I make you think they are. They can't be, because otherwise it would be very hard to know where they are in memory. So I do have a naming convention that's generally speaking based on where they are in the spreadsheet. But recur allows you to access that without knowing it. So recur 1. See, we've got a nice little color syntax highlighting in the editor, and the output is colorful. So at least it's not like kind of dull looking. Oh, we're going to call it. So let's say we're going to get the Lambda of 5. Should be 120. Oops. Inside there, I got to do it. All right, hold on. Okay. Boom, boom, boom. Oh, go ahead and control that drift. Okay. There we go. All right. Okay, what did I try to do? Oh, you know what? I don't think I actually added the little hocus pocus to my, I don't think I added it to the REPL. That's okay. That's just something I gotta fix. Okay, so let's take the code and just do it. Let's just do it. We'll create a new sheet. Control Shift L gives us a nice fresh Lambda. And this is the Lambda Editor, which on my machine, which on my thing looks kind of tiny, but on most normal machines, it kind of squeezes in there. So here we have the Lambda. We're going to convert this into a factorial. So we're going to say, Control T. And we're going to pass 5. We're going to accept that. All right. So you see up here is what we converted it to. So we take this nice, easy way of coding it so you can actually read and see, and it does do some pretty printing back and forth when you move around. But I took the Lambda and I applied the 5 value to it. This is the actual name of the Lambda under the hood, and the result was 120. Okay, so now, oops, instead of hard coding that, what we're going to do is we're going to say, first of all, let me Control X, Control V. So we moved it, and now you'll see it has a new name. And now we can just say, let's just put 5 here. And then in place of this, we can, you can do it here, but you can also call the familiar function arguments dialog. In this case, we want to grab that, right? So it's A1 is the argument. We'll say, okay. Now you'll see that it passes A1, the reference to the Lambda, and returns the appropriate amount. I'll explain the signature a little bit. This is the code. And it does handle things like strings and everything appropriately. So there's no limit inside the editor to coding normal scheme code of any kind. The scheme env is a reference to the to an environment. It's a cell where I keep the name of the environment plus a hash, which changes when you change the environment. So when you add a directory to the search path, or you add a library you want to load in, then that will trigger the change. One of the problems I had originally was making everything volatile. Not a good idea for spreadsheet performance. So in this way, we have a clear dependency hierarchy from the environment down, and only if the environment changes, or if a Lambda or function changes that another cell is dependent on, will it trigger the change. And that's really sped things up. So I'm quite happy with that. Doesn't look right, but then again, you don't have to look at that. You don't even see it in the editor. It's just there as a thing. So I'm always rebuilding in a preview. When it goes green, it means it's changed, and you have the option to accept it and see what you get or not. So now that we have the Lambda code, and we see that it works, right? It's calling appropriately A1 and giving you the result. We can generalize this now by making it a named function. So we'll go back to the Lambda tab. We'll do Control D. This gives us the define Lambda operator. So basically, I've got 4 functions that create or use Lambdas. I got the Lambda function, which is an actual Lambda symbol. I've got the define function, which allows you to give it a name that you can also then use in the REPL once you evaluate it. We've got eval, which really means evaluate a form. It doesn't mean eval in the expansive eval concept. But if I have a named form and it takes certain number of parameters, I use eval to call the form with those parameters. And then I have apply, which allows you to feed a list to a variadic function like plus. So I'll show you what those look like in just a second. But now you'll see that when I first created the Lambda, it gave it the name Deep Thought, because that's what the default thing does. And of course, it returns 42. But we want to change the code, Control V, and we want to, okay, so now you see it's gonna compile the Lambda, gonna accept it. I should have changed its name. I didn't. Oh, because I didn't change the name. I want the name to be fact for factorial. Okay. There we go. All right. So now that fact exists, and I can actually test it here too. Fact 5. Boom, 120. Conversely, anything I define in here as a definition is, at least for the life of the REPL, available in the function. This is why you want to maybe develop it here and then cut and paste it over there. That's another reason why, if you see the output when you do pass it, and I give it in a way that's easy to cut and paste, because cut and paste is sort of that's what you do in Excel, right? All right. So now we have this Lambda called fact, and this allows it to be referred to by location as well. So we're going to give it a proper name. Call the name manager, create a new one, and we're going to call it fact. Okay, we'll call it factorial. I'm just afraid of maybe kiboshing something else out there, so we'll call it fact. There's like 400 functions in in Excel, and I don't want to confuse it with them. Okay, so now we have a fact named thing. So now we got 2 ways. We've now named it 2 different ways. One way I can get to it from the scheme world, and now I can get to it from the from the Excel world. So instead of Lambda, we're going to go ahead and say, let's just delete that guy. And we're going to insert, we're going to call evaluate, right? And right now that's what it says. I'm going to swap that. So now we're going to call we're going to call factorial. That's the full name. And we're going to call it with A1. And there you go. So what we did was we went from an idea in the REPL to a Lambda, a one-off, just to see if it works and I can relate it. We realized we're going to need it in more places. Oops, sorry, that kind of went over there. And now we've given it a name and we can refer to it either by its Excel name, but you can do the same thing. You just copy that. It's simpler. Control C. All right, so that's fine. Uh-oh, what'd I do? Control Z is my friend. Okay. No. All right. I botched that. That's some live coding here. All right, so let's do something different. Let's do it this way. We're gonna start with, my magic mouse keeps taking me places, 20, and we're gonna say equals A1 minus 1, 19. Go ahead and say Control C. And we're gonna go, let's see, we're gonna go to, yeah, we'll do the first 20. Control B. Boom. Okay. So now that we have our values, let's go ahead and do eval. Control E. We're going to, oops, no, I'm going to go Control X here. We're going to fact the old-fashioned way, although probably better to do it this way because then it keeps the references. It doesn't really matter. And we're going to go A1 and accept. All right, so I'm going to have to stretch this out. Going to have to name, stop, there we go. We go to, we're going to call this numeric number. Okay, there we go. That's good enough. We can make that a little bit smaller. So now we're going to say Control C. And we're going to just all the way down. Boom. So it computed all of the factorials instantly through the whole list of them that we had there. So it did the normal cut and paste that you would expect an Excel function to do. And in this case, because we're using eval against a named function, there's no recreating of there's no recompiling of that code over and over and over again, as could happen if you just used a Lambda there. So the utility of a Lambda is to try something out, then you give it a name, and then you use it everywhere. I have another, let me just do it this way. Going to highlight that. That's going to be general. I want to left align that. Left align. Yeah. Okay, let's just see what happens. Okay, so I'm going to go ahead now and say, I'm going to insert a new, I want a new function. So we're going to, let's test it over here first. What we want to do is compare and see which one's bigger. I just want to show how you can also write functions that compare the relative values of these things. Lambda inside of a lambda. I'm going to print out whichever one is bigger. Like I'm missing. Oh yeah, I am. There it is. So now we're going to say if greater than AB, A, otherwise. Pass in 5 and 6. Oh, in the wrong. Okay, control. So 6 is bigger. So we know the lambda works. We can now grab it. So let's go back to our lambda tab. And again, you don't have to organize it the way I'm organizing. I'm just doing this to keep things simple. We have other tabs you see down there for domain modeling, for connecting databases and doing routes for the web server, which I'll show at a different time. But we now have the code for this. So let's go ahead and create a new named one, Control Shift D. We'll call this which is bigger. We'll just save ourselves some typing, and we will compare. Okay, so this is just the function. What did I do? Oh, I didn't change it. Okay, Control V. There we go. So now we've got a function which is bigger. Okay, it's bigger, so it works. We can also now use it in the REPL now that it's been named. So we'll go back to sheet 1. We'll call E for eval. We will there, and we will say what A1 and A2, right? Okay, so 20 is bigger. So now we're going to do the same thing. We'll grab this, Control C, and Control V. Oh, it didn't copy the things correctly. That's weird. All right, hold on 1 second. Delete. Stupid mouse. Okay. What do we got here? 1, 2. Oh, no wonder. What I wanted was B1 and B2. Not that it really matters. I think you get the concept, but this is how you work in Excel. You're constantly moving around, trying formulas out, doing things. And so now we got it. Now I can copy, Control C. There we go. Okay, so there's a little bit of that. Now I haven't shown apply. Apply is one of those functions that takes a variadic function. So this is one where it can use 0 to n parameters, well, at least one maybe. So we'll use apply, Control A, just to show you what that looks like. By default, we use plus, and we have this named array value, and this is basically going to convert to a proper list. So we're going to apply the plus function to this list, and of course it returns 10. We can in here change it. Oops, I'm going to accept. So it changes it. I can also refer to a range. So let's add up the first 5 or 4 of that guy. So let's go ahead and use the function editor for that, although we could type it in. Instead of this, we're going to use a range. We're going to call A16 to A20. And we're going to say OK. And it's going to give the answer 15, because that's what those add up to. So that's how you would do apply, and you would write a function for apply in the same way as you would in normal scheme. I don't know if you're familiar with the syntax, but it looks something like this. Lambda name, and then do whatever you're going to do. So if you provide name or whatever you want to call that parameter without the parentheses, then it will work with apply and pass a list in. So really what you want to call it is something that you can use like a list, because that's what you're going to get from apply. And then from within there, you can do whatever you need to do with the list. If it's a simple list, you can just call it. If it's a multi-dimensional list, then whatever. The point is that it can be anything, and you can highlight any regions and pass those in as inputs and work them. But in this context, you're working in pure scheme. You're not conscious of cells and cell names and stuff like that. So there's some advantage to that. You do the same function in VBA, you got to be iterating through a range and making sure you get the cell coordinates right and all that. I've done all that for you and given you a nice Lispy list to work with when you do it this way. Okay, so let's do something a little bit kind of more interesting. Underneath the hood is a lot of functionality not loaded. For example, we have logic programming. So I just loaded mini Canron into Excel. So we can do something like what's a good one? Okay, I'll create a function called appendos. Let's test it here first. I think that's going to do run view. Yeah. We want to make some fresh variables. So basically what appendos is going to do is you give me a list of like 1 to X, and it will show all the combinations from 0 in the first list to all the items in the second list, and iterate through increasingly moving them over so that what you end up with are all the different ways these two lists could be appended to give you the same value. That's basically what this kind of completely not useful but demonstrative example will do. It calls the appendo function, which is defined in mini Canron. Just check that it unifies with. Should work, I think. All right, so now that's been compiled. So we can try appendos of 1, 2, 3. It's simple. And there you have it. It's not laid out pretty here. I got to work on some pretty printing for it. But basically, the first answer is this. The second answer is this. The third answer is this. And the fourth answer is this. So obviously, with full access to mini Canron inside of Excel, you can do logic programming just like you can with core logic in Clojure. I think that's a particularly interesting thing, but it's one of many, many things under the hood. There's a object-oriented programming model that you can kind of like a little simple object-oriented stuff. There's a unit testing. There's all kinds of just a whole bunch of stuff. And we're working on tutorials and things like that. And I'll be doing blog posts on these kinds of features over time. But there's a lot already under the hood that is quite, I think, valuable. And by the way, you can now, because it's been defined, you can call it as it is, but I'm going to go ahead and make a proper function out of that, proper defined name. So that on restart, it will work. Control C. Go back to the tab over here. We will Control Shift E. We'll call it appendos. It's going to redefine the same function, but that's okay. This is what you do. Once you know it works, then you go ahead and put it in a place where Excel can remember it when it restarts. Control V. And we will accept. And now we have appendos as part of this list. So next time you open up the spreadsheet, it'll be there, it'll recompute, it'll be there, and you can start using it, and it'll all your downstream sheets that use it work with it. Whoa, come on. It did not change my code, which I can do again. I think I got a little bit of a there's multiple ways I should be able to accept the code, but I didn't get it to regenerate the formula until I did that. So there we go. Now appendos will work. You'll see also the instant pretty printing. So when you move around from function to function, you don't have to write this, and you don't have to mess around in the formula bar at all. Okay, let's see if there's something else I wanted to do. I could go further, but I actually think that gives you at least a flavor of working with the 4 different functions, 4 different Lambda functions. I'll just review it briefly. We got insert a Lambda that lets you kind of experiment. It's one way to experiment. Another way is to try it in the REPL. Once you've come up with something you want to reuse, you give it a name. It's also important to give it names, the name that you'll use internally in Scheme or any of your other Lambdas, but to also give it a name that's as Excel thinks of it. The advantage of the name that Excel would think of it as, so if we go back here to factorial, that fact name, the advantage of that is the engine will automatically pick up changes and propagate. Now, I've already done things behind the scenes to make sure that that works, so that advantage is actually almost gone, but it's still a good thing to do as a practice within the Excel world. They give lots of names to things, and it can't hurt, because then any other Excel function could potentially call into it too. Yeah. So anyway, so it's always good to give names. I didn't do it to these two because it's just a kind of a walkthrough, but that gives you the flavor of it. So let's go back to, God, this magic. This thing drives me bonkers. All right, let's go ahead and flip back to the slides. How are we doing on time? Okay. We've gone on for a little over an hour. Okay. All right, let's see. All right, so pick up where we left off. So near term, we got RC1 release coming in the next week or two, and we'd like people to download it, trial it. We'll put out an announcement on our website, apexdatasolutions.com. Obviously, you'll be able to reach out to us. I'll give some contact info. V1 will also have features I didn't demonstrate because right now we're in the process of hooking it all up, as you can deduce from my the scope of what I showed. Data REPL and access for transforming access data to RDF. And there's a native data backend in Excel workbooks. So once you open an Excel workbook as part of this, like through the template, you'll automatically have the ability to store information in both a NoSQL form and a SQL form. The SQL form is using SQLite, and the NoSQL is using LightDB, which is basically like an embedded MongoDB. So literally you can do anything you want with the data associated with the workbook, and you don't got to go through contortions of setting up ODBC or complex ADO connections, and we'll have wrappers around doing most of that anyway. So even if you do need to reach into a SQL server or reach into an access database externally or whatever, that will be baked into workbook. So the anti-pattern here that I'm trying to get people out of, people notoriously use Excel as a database. And that's partly because connecting to real databases is kind of hard, and cramming data in these sheets is kind of easy. So I'm trying to make it much easier to do the right thing, which is to have data at your fingertips, but not necessarily store all of it physically in your spreadsheet. The spreadsheet should be about modeling. It should be, really it should be about modeling and presentation layer stuff, like maybe coming up with reports and things like that. Also for experimenting, it's like a giant playground for how you think about your business or your problem space. And then web serving, that's going to be kind of freewheeling in the standard edition. I'll give you the ability to create routes and hook them up with Lambda handlers, defined all in the spreadsheet. Click a button and then go to your browser and play with it. In professional is a bit more structured to that. It's more about the linked data vision, but you'll also have the freedom to add whatever you want to it, front end, back end stuff. Yeah, what we want to do is get folks, encourage them to work on some hard problems and share library code in GitHub. I think this could be a fun area for community involvement, coming up with projects that add, real value there. We also plan at some point through Apex Agora, which is kind of our back end to help support people who want to maybe monetize things that they build in this setting. So lots of options there. Oops, on the wrong way. There we go. We're looking for folks who are interested in learning more about this approach and with us, and also providing consulting services to customers. We have some large opportunities lining up once we do release, and one of them with a substantial government entity, and we've got other doors opening. So we will need to have people learn how to do this and support it pretty soon. Midterm, the professional edition is going to feature a lot more programmer-friendly things. We'll have a proper code editor environment that's sort of like kind of like an IDE more than this. We'll be able to hopefully have something resembling a proper debugger, and we're going to containerize web projects that you can kind of generate from your spreadsheet. These would then be runnable on any platform that runs .NET. By default, I'm going to focus on .NET framework and Windows servers because of the reflection emit problem, but it's also an option to store it as a ASP core project, in which case you can deploy it to Linux and Mac and whatever as well. And there'll be a lot more. I've got all kinds of thoughts on that I'll be putting in our blog. Long term, really this product is about, I want to open up new avenues for Lispers to work in the vast universe of custom office solutions. And I think that's a big deal because it's a mainstream world. It's a world everything from big corporations to small businesses know. I was always thinking, like, how could you possibly make Lisp, any flavor, more popular? And you need a lever, right? And what was the phrase? A lever big enough can move the world. I think Excel is that lever potentially for Lispers to add value in that world. And, I hope you agree, and would love to hear your thoughts about that. We also have a product after Pro of Accelerate called DomainMaster. This is what really brings the order to the change propagation problem to support interoperability across organizations. It uses distributed transacting, and everybody gets their own copy of long-term storage. And from this, they create a local copy of what we call a domain cache. It's really Unify, but in a box. So DomainMaster is really kind of like the desktop flavor of Unify, and Unify's the more enterprisey data mart or data center centric version of it that runs in a more distributed platform. So all the different pieces underneath the hood in DomainMaster can be deployed with Unify on much larger networks. All right, so in closing, hope you enjoyed the preview and are interested to check it out in the coming weeks as we release V1. I promise more and more interesting demos in the future. If you're interested, I'm happy to do them, and we can talk about how to maybe the next one will be much more closure centric. And there's ways you can contact us, general email about the product and services and stuff like that, info@apexdatasolutions.com, my personal Apex email. And we have our website where you can sign up on our newsletters and stuff like that. I'm going to start blogging soon, as soon as I get this release off out the door. And there'll be other ways to get involved that we'll be announcing. And I would like to, be part of this community as well in the future.